Hello and welcome to the CellCraft tutorial. In this video, we'll walk you through how to create your own custom plugin in CellCraft. Let's get started. This is the workflow we're going to add to CellCraft today as a plugin. It's composed of a few simple scripts, starting from an H5AD file as input. The goal is to generate two visualization outputs, a heat map and a bar plot. As you can see in the diagram, the workflow begins with a Python script. From there, the data is processed in two directions. One branch runs an R script to create a pseudo-time distribution heat map. The other branch selects top genes and draws a bar plot. It's always a good idea to sketch out the entire workflow diagram before implementing your plugin. It helps you understand the data flow and script connections clearly. Now let's take a look at the parameter conventions they follow in CellCraft. Let's begin by looking at how to write a Python script that follows the CellCraft plugin conventions. CellCraft passes all parameters through the command line using sys.argv. So first, make sure to import the sys module at the top of your script. Remember, sys.argv open bracket 0 close bracket is the script name. Actual arguments start from index 1. All arguments passed from CellCraft are strings by default, so you must explicitly convert them to the right type. For example, use int, float, or bool, depending on what your script needs. For optional parameters, CellCraft sends the string none when no value is provided. You should check for this string in your script and replace it with Python's none as needed. Now let's look at the R version of this convention. Just like Python, R scripts receive arguments through the command line. Start by calling command args, trailing only true, to capture the arguments. All arguments in R are also received as character strings, so you'll need to convert them to the right type using functions like as.integer or as.numeric. Optional parameters in R are also passed as the string none. You can handle them using if-else or similar conditional logic. For example, if the string equals none, treat it as NA or skip that step. To summarize, both Python and R scripts must accept command line arguments in order, perform type conversion, and check for none to handle optional values. Now that we understand the parameter conventions, let's move on to our real plugin example and walk through the scripts one by one. The first script, tenant input py, is responsible for preparing the input data. It takes an .h5aid file containing single-cell transcriptomic data, filters the cells based on annotations or interactive selection, and extracts key components for GRN analysis. These include the expression matrix, pseudo-time values, and a list of selected cells. Next, we use an R script called pseudo-time distribution.r. This script generates a density plot that shows how selected and unselected cells are distributed along the pseudo-time axis. Now let's look at select top genes.py. This script analyzes the expression matrix and calculates the average expression for each gene. It then selects the top genes based on their average expression, top n genes with the highest average expression values. Finally, we use barplot.py to create a bar plot of the top genes. Using the Plotly library, it generates an interactive horizontal bar plot that visually compares expression levels. Let's test the scripts created according to the convention. If the desired output is displayed normally through the test, the script writing is complete. CellCraft installs all required libraries based on standard dependency files. For Python, include a requirements.txt or an environment.yml file. For R, use a renv.lock file. These files should be uploaded along with your plugin. If your plugin includes custom code stored in folders, you can add that directory to the system path. In Python, start by getting the current scripts directory, then append it to sys.path so Python knows where to find your modules. After that, you can import the function or class as usual using from and import. In R, it's even simpler. Use the source function to load your script and then call the function you need. If your plugin requires packages that are not available on PyPI or CRAN, you can upload .whl or .tar.gz files directly. Just make sure they are listed in your dependency file and placed in the same directory. Now we're ready. Next time, we'll upload these scripts as a plugin,